Welcome to Google Cloud's digital conference, Better Code Faster. I'm Zihon, a solutions architect at Google Cloud. I'm going to be talking about serverless fundamentals, building with functions and apps today. We have Googlers on standby to answer any of your questions live, so please click on the icon to your left and ask away. So, serverless fundamentals, building with functions and apps. In today's context, I'm sure many of you have heard of the term serverless being bandied about in various different ways. So you might have heard about serverless being mentioned in the same breath as a framework, as serverless technologies, as serverless programming models, as serverless products. So it seems that serverless is used in many different ways. But what exactly is serverless, and why as a developer I should be looking at and thinking of picking serverless? So in this session, I'm going to talk a little bit about serverless, what it means, how we can use it, how we can implement it, what are some of the considerations that we should keep in mind, and more. Now, before we actually go into what is serverless, first, we need to start off with looking at the evolution of compute. Now, in the grand timeline of how compute has evolved over the years, on the extreme side, we have on-premise infrastructure. So that's how all compute started off initially. So we have a bunch of servers that we buy, that we provision, that we install, and that we set up in our own data centers. We have people who are dedicated to looking after these servers, to patching these servers, to maintaining these servers, and to keeping these data centers secure. Now, on one hand, in this on-premise setup, we do have the full control and ability to customize our data centers and our infrastructure and our servers. However, there are some downsides to this. Because of this on-prem infrastructure, there is often a long lead time for new resources. If you do happen to need new servers, it takes a long time to provision them, to request to buy them, to get it set up, to install them, and to harden them. And all this leads to a very inflexible model in which it takes a significant amount of time to increase your compute capacity. And you don't want that because that means that you're going to be a little bit inflexible in terms of how you can scale up and down your compute to meet different demands. Of course, it also increases the total cost of ownership because not only do you have to focus on the developers developing the applications, you have to focus on maintaining a team to maintain and upgrade these servers, to secure the data center, the operational cost of operating the data center, and a lot more. So in the on-prem infrastructure, your total cost of ownership is going to be a lot higher. And then eventually, after the on-prem stage of compute evolution, we move to virtual machines. Now, when we talk about virtual machines or VMs, as you might be familiar with, they're a little bit better in the sense that they abstract away the underlying hardware, which leads to more efficient use of your hardware. However, there are also some significant disadvantages with using virtual machines. Because they abstract away the entire machine, it is often a very heavyweight process and it takes a long time to boot up. And in this case, for VMs, you're still going to be doing some kind of infrastructure maintenance and provisioning. In addition, it takes up a lot of CPU cycles and RAM, and it's not the most efficient way to quickly deploy new applications. Now, after VMs, some companies started looking into containers as a way to address these issues. Now, Google being one of these companies that worked with containers earlier on, and we are now at a stage where we deploy billions of containers into production a week. Now, what are containers actually? So containers are another way of packaging your application and your libraries together into an isolated piece, which can then deploy across operating systems. They are a much more lightweight alternative to VMs, and as a result, you can probably stuff many times more containers into a physical machine than you can a VM. However, there are also some trade-offs with going towards containers. One is there's still a slight learning curve involved, and when you think about deploying containers at scale into production, you now require things like container orchestration, container lifecycle management, and a lot more. So that's where the learning curve increases as well, and you need to pay attention to these things. Now, on the other end of the spectrum, now we come to serverless. which is the focus of our session. What exactly is serverless in terms of the compute evolution? Well, the first thing that comes to mind when you talk about serverless is that you don't see any servers. There's zero server management. So you just focus on building a business application, and you don't worry about provisioning servers, taking care of your servers, running your servers. In addition, you only pay for the resources that you use and nothing more. On the other hand, a trade-off for some, which is actually an advantage to others, is that you don't have access to every knob and dial and setting. You're not able to fine-tune your server parameters as that's managed away from you. And that is how serverless is in terms of the computer evolution. Now, when we talk about serverless, it's often helpful to sort of change our thinking in terms of two different models. The first model is the operational model. When we talk about serverless, as I've mentioned previously, the first thing that comes to mind is no servers. So what does it mean when you say no servers? Of course, as developers, we all know that there are actually servers running behind the scenes. But for serverless, in the operational model, as a developer, I don't actually see the servers. I produce and write my application, I deploy it, and I don't have to worry about where to deploy my application, how many servers are there, and how do I start up new servers. All that server management is being handled for you, and that's what we mean by no servers. Of course, in this case, when you do deploy an application, things like upgrading your libraries, hardening your server, patching your applications, authentication, securing your servers, all that is also managed for you on your behalf by Google. And that leads into what we call fully managed security. In the operational model for serverless, as a developer, all you need to do is to focus on writing code, deploying your code, and that's it. In terms of managing and securing your servers, we are going to be taking care of that for you. You don't have to be worrying about the latest security vulnerabilities and things like that. All the patching will be handled for you, or the upgrades will be done for you. One significant thing about the operational model when it comes to serverless is what we call moving from a pet mindset to a cattle mindset. Before serverless, you might be treating your servers as pets. So that's what we mean by a pet mindset. You only have a few servers, hence they're all your pets. You know them intimately. They're all different from each other, and you know them very well. However, in the serverless model, because you no longer have any servers and they are managed for you, you move to what we could like to call a cattle model, in which case you have a lot of interchangeable servers that are invisible to you, and you don't really bother about which server you deploy your application on. And that's what it means by serverless. Lastly, of course, in serverless, you pay only for usage. And that's a huge advantage for a lot of people. That means that instead of having servers on your premise being idle and taking up CPU time and electricity and paying for that, you only pay for what you use. So when you have a spike in requests, we'll spin up more instances for you, and you pay only for that. On the other hand, when demand dies down, we spin down those instances and you don't have to pay a cent. Essentially, you pay only for what your application needs. And that's how we need to think about serverless in the operational model. Now, the next model we need to think about is the programming model. Very often before serverless, people tend to program their business applications in a sort of monolithic architecture and deploy it as a monolithic application. When we move towards serverless, we tend to break down our monolithic application into tiny little services, or what people sometimes call microservices. Now, there are a lot of advantages to this programming model, chiefly being that you are now more responsive and agile to business change, because your code is now encapsulated in tiny little functions. You are going to be able to focus your business domain knowledge in each function. You are going to be able to test each service independently. You are able to grow and scale each service independently based on what they need. You are also able to deploy each service independently. As a result, you are going to be able to ship stuff to production a lot more quickly than as compared to when you're running a monolithic application. Another thing that comes to mind for the programming model when we talk about serverless is about thinking in terms of events. So when you're doing serverless, you might have a lot of little applications and functions lying around they're just waiting to respond to events. And that's great because a lot of the times what we do in our business applications is actually just responding to events. For example, a user could be uploading an image to Google Cloud Storage. And then you have a function that spins up in response to an event that's emitted by cloud storage. And that service now does things like metadata extraction, metadata analysis, and image resizing, for example. And that's how one can think about events in the context of serverless. The other thing, of course, is that serverless doesn't refer to any kind of proprietary technology. It is the way you think about your operational model and your programming model, and it's really open. So if you know Python, you know Go, you know Node.js, you can take your knowledge of the language and you can write serverless code anyway. So having said that, I'll just quickly give an overview of serverless on GCP itself. So in terms of compute, our serverless offerings include things like Cloud Functions and Google App Engine. For persistent storage, we have Cloud Firestore and Cloud Storage. In the domain of chat, we have Google Assistant and Dialogflow. When it comes to messaging on GCP, we have things like Cloud PubSub. And for data and machine learning, we have several serverless offerings. These include Cloud Vision API, Cloud AutoML, BigQuery, and Data Studio. In the field of continuous integration and continuous delivery, we have products like Cloud Build. And in the area of security, we have Firebase Authentication and Cloud IAM. Now, when it comes to observability, we have a bunch of serverless products as well. These include Stackdriver logging and monitoring, as well as Stackdriver trace. So keep in mind that this is just a subset of the serverless offerings on GCP. And all these are used in the demo that I'm about to show you. So a little bit of background on our demo application first. So what I'm going to be demoing is what we like to call the Serverless Hipster Shop. It is a full-blown e-commerce web application that's built entirely on serverless products on GCP. The code will be made available after the session, and you can check it out on GitHub, and you can see exactly how we built, developed, and deployed this application. So let's take a look at the application. So here we have the serverless store, and I've already signed in, as you can see on the top right, through Firebase Admin. So let me quickly walk through the functionality of this store. So we are selling a bunch of hipster products. We have dog collars, bones, record players, terrariums, and these are simply the product listings on our store, and a vintage typewriter as well. Now, I as a user, I can click around this site. I can go into my shopping cart and see that I already have a dog collar there. I can choose to remove it from my cart. I can go back to the store. I can even choose to upload my own item for sale on the serverless hipster store. So we can upload an image. So I'm going to sell yet another dog collar. I'm going to upload it. And the upload is complete. We'll give it a description. And then we'll give it a price, of course. And we're ready to go. Let's click submit. And then we can see our dog collar here being submitted to the store for sale. And then, of course, I can purchase products as well. I can add to cart. I'll add this item to cart. I can add the record player to my cart. I can go to my cart. And I can actually check out. And here's a checkout page. As you can see at the bottom, there's a field for me to enter my shipping and payment details. And of course, I know better than to enter my credit card details on the live demo, so I'm not going to do that. But you can see that in the payment section, there's already payment integration with both third-party services in terms of Stripe Pay here, and then with Google Pay as well. So there you have it. That's a full-fledged e-commerce web application built entirely with serverless technologies. Then let's take a deeper look at the architectural stack of our application. So let me quickly go through the different aspects of the stack here. So first we have the presentation layer, and that's where we have App Engine running. It takes care of everything that's related to the shopping cart, to the product catalog, and the orders. We also have the processing layer, where we have both synchronous and asynchronous operations. For the synchronous operations, we are concerned mainly with data requests, for example, getting a list of products from the database. And for the asynchronous operations, we are leveraging on Cloud PubSub and Cloud Functions to do things like, for example, product labeling, payment processing, and image compression, as you can see from when we uploaded the photo previously. For the backend, in the data layer, we are running on Cloud Firestore, which stores details like product metadata and order information. Now, on the other side, we can see that we also leverage things like cloud storage as a way to store all of our product images. We leverage on Cloud AutoML and Cloud Vision API to add machine learning smarts to our application. And for analytics and data analysis, we rely on things like BigQuery and Data Studio. In terms of third-party integration, we also integrate with things like Stripe for payment and SendGrid for sending emails. And internally with other Google services, we integrate with Google Pay and Google Assistant, and also things like Dialogflow for chatbots. Now, on a platform level, we leverage things like Firebase authentication that covers our sign-in portion, Cloud IAM. We use Stackdriver logging and monitoring, as well as Stackdriver trace for logging and all the debug reports that you need. We also use Cloud Build to leverage on building and deploying our application to production in a full-fledged CI/CD pipeline. Now, there's a lot of different aspects of our application, but one way to think of it is to break it down into 4 different quadrants. Now, for the first quadrant, we have what we call the fundamentals of serverless, building things with functions and apps, and that's the session that you're currently watching. Now, when we move beyond that, we can classify the other quadrant in terms of moving beyond serverless and beyond compute into data and machine learning. And that's another session that you can tune into if you are interested in that. Now, for serverless beyond GCP, we are going to be talking about how you can take advantage as a developer of both Google services and third-party services. And lastly, even though I mentioned that in serverless, we don't need to deal with any servers, we still have to consider serverless in production. We still have to think about monitoring our application and checking that it's actually working as intended. Now, for this session, we'll be focusing mainly on serverless fundamentals, building with functions and apps. And here's a quick look again at this particular quadrant of the technology stack. We have the presentation layer, where we have App Engine running as the front-end service. We have the processing layer with both synchronous and asynchronous operations, and we have the data layer as well. So, applications and functions. What exactly are we going to be covering in this session? So for apps and functions, for applications, we are going to be covering the App Engine standard offering from GCP, which allows you to build highly scalable serverless web applications. Now, there's another product that's known as App Engine Flexible, but we won't be covering that here in this session. Now, in terms of functions, we are going to be talking mainly about Cloud Functions, which is a way to develop on our event-driven serverless compute platform. And you might ask yourself when we should choose between App Engine and Cloud Functions, but don't worry about that. We'll give you some tips to help you make the right decision and some example use cases for both. Now let's take a look at the App Engine flow. So firstly, we have the presentation layer. So this is our front-end service that's deployed on Web Engine. Behind that, we have a processing layer where there's lots of synchronous operations happening. So this happens when the user clicks around our demo site. So for example, when the user loads the main page, when the user looks at product information, when the user checks out, when the user makes an order. So all these results in synchronous operations that make requests to our backend service, backend data store in Cloud Firestore. Now, in terms of what a front-end web application is, let's take a closer look at it. So it's a very standard web application that's developed in Python 3.7. We are using the Flask micro framework, templating with Ginger. We are using Firebase for authentication to handle all of our sign-ins. And we integrate with Stripe and Google Pay for payments. We also leverage various Google APIs, such as Cloud Storage, Cloud Firestore, Cloud PubSub, and Cloud Trace for monitoring and logging. Now let's take a look at the processing layer for the asynchronous operations. Now previously we took a look at the front-end web application. Now we'll look at what actually happens asynchronously. So in the processing layer, we actually have a product called Cloud Scheduler. So Cloud Scheduler will emit events. And these events actually trigger Cloud Functions, which then wake up to handle that request asynchronously. And Cloud Functions handles all events that are emitted by Cloud Scheduler. And in this case, Cloud Functions will either interact with the Cloud backend Cloud Firestore or send an email or both. So we'll take a closer look at how this works. So I mentioned Cloud Scheduler earlier. So what is that exactly? So Cloud Scheduler is one of our serverless products we offer on GCP. And you can think of it as essentially a managed cron service. So why do we need a managed cron service? For several reasons. Because in terms of developer efficiency and productivity, when we have a managed cron service, we essentially now decouple our scheduling code from our business code. This allows you to just focus on writing out business logic, and then you let Google handle all the scheduling concerns, such as when you should be waking up, how often you should be waking up, and also retries should it fail. And all this is managed and extracted away from you. So for example, in this case, we want to run code on a time schedule, which is why we use Cloud Scheduler. At a fixed interval, Cloud Scheduler emits certain events, and then these invoke Cloud Functions, which then work on our backend data store and sends out an email. And that's how the interaction flow works. Now, in terms of Cloud Functions, let's take a closer look at what it's actually doing in the backend with a specific example. In this example, we'll take the email sending functionality and we'll dive deeper into this. So what is actually happening behind the scenes? What are we deploying to production? So what we are deploying to production for Cloud Functions is essentially something that's developed, a piece of code that's developed with Node.js. We use some dependencies such as Google Cloud Firestore, SendGrid for sending email, Firebase admin for authentication, and Puck for templating. So as mentioned previously, these Cloud Functions are triggered whenever events are emitted by Cloud Scheduler, our managed cron offering. And what does our Cloud Function actually do in this case? Well, so our Cloud Function queries Firestore for items that have been in the cart for more than a certain period of time. It then generates an email of all those items and sends an email to the customer reminding them of items that they have left behind in the cart. So here's a piece of sample code as to what the Cloud Function is actually doing. Now this is not exactly a one-for-one replica of what we deployed in production, but it's close enough and it's easy enough to understand and reuse. So you can see here we are using the async mechanism, which allows us to write asynchronous code in a synchronous fashion. So first, we begin by querying Firestore for our forgotten cart items. So it gets all the carts where it's older than a certain period of time. And then after that, we iterate through each cart. We get all the items, and we construct the email, and we send the email via SendGrid to remind the user that, hey, you have some items that you have put in your cart, but you have forgotten about. Would you like to take a look at it again? So you can see that this piece of code is very focused purely on the business logic. It is short, it is concise, and it can also easily be reused by other services, not just by our front-end web service, because this is purely focused on cards and emails. If you happen to have another new business flow which requires functionality like this, you could simply emit another event to wake this Cloud Function up and call it, instead of having it encoded inside our application. Notice also that in our Cloud Function code, there's no code for scheduling, no code for retries, no code for logging, monitoring, and debugging. All those are managed and extracted away for you by our other serverless products, so you're purely focused on writing your core business logic. Now, apps versus functions. Let's talk a little bit more about this. Now, when you think about serverless compute on Google Cloud, for this session, we have been talking about these two products, App Engine Standard, and Cloud Functions. Now I'm going to go a little bit more into when we should use one over the other, or which is the best use case for App Engine or Cloud Functions. Now in the case of App Engine, what it actually is that it's a highly scalable serverless web application platform. You can use App Engine Standard to deploy and scale your applications that react to requests. In terms of Cloud Functions, they are an event-driven serverless compute platform where you deploy and scale functions that respond to events. So if I use to writing things like maybe an Express.js application, you can just run that on App Engine. Same for Python and Go support as well. You don't need to rejigger application. You simply just deploy it through a descriptor file and you're done. And Cloud Functions can also easily be integrated into your CI/CD pipeline through things like Cloud Build. And of course, if you know languages like Python, Go, or Node.js, you can easily use this across the entire stack from App Engine to Cloud Functions. Now, when should a developer choose App Engine? I get this question a lot, and let's take a look at some of the considerations. Now, firstly, if you have web traffic that requires minimal latency. For example, you have a user clicking on a live website. It could be an e-commerce site. It could be some other business-facing site. Now, you do require minimal latency for this because whenever a user is interacting with a site, you want the response to be as fast and snappy as possible. You'd want to have some kind of latency in between the user's request and the response. Studies that Google has conducted has shown that even just an increase in response time by half a millisecond or a millisecond decreases your conversion rates drastically. So you really want things to be snappy for a web application. The other one is the level of abstraction that you're thinking about. If you're using a web framework, for example, Flask, as we mentioned before, that supports multiple routes and HTTP methods, you really want to deploy it on App Engine because that's our way of deploying managed serverless web applications for you. And it's an abstraction that maps well to developing web applications. If you need support for custom domains, App Engine will be a good fit as well. And also, it's available in a lot of many regions globally around the world, should that be a consideration as well. Now, when should a developer choose Cloud Functions? Now, when you think about this, Cloud Functions are very suited for background tasks that are less sensitive to latency. Things like asynchronous data processing, image compression that can happen after the image has been uploaded, things like that. And that's when Cloud Functions is going to be great. Cloud Functions are also good for single-purpose reusable code, as we have seen earlier on with the example of sending email. Now, when you have a very focused email sending service deployed as a Cloud Function, your Cloud Function can be utilized not just by the front-end web application. You can easily compose that function into many different work streams and workflows. One thing to also take note of is that if you have a piece of business functionality that always reacts in response to certain events that are being emitted, for example, when a user uploads an image to cloud storage, when a message gets published to a message queue, you're going to want to look at Cloud Functions because those have first-class understanding of events that are being emitted by other products. The other thing is retries. One interesting thing to take note of is that if your Cloud Function is going to be connecting to various third-party services which you don't have control over, and these are sometimes going to be flaky, Cloud Functions are a good fit for your application because all that retry logic, how many times you should retry, exponential back, or things like that, that's all handled for you by Google. So you don't have to sprinkle complicated retry code throughout your application. Now, auto-scaling. I briefly mentioned this before, but both App Engine and Cloud Functions auto-scale seamlessly for you based on your demand. Now, they can seamlessly scale up if you have increased demand or seamlessly scale down if you have decreased demand. However, there are a few technical nuances to keep in mind when we look at auto-scaling for both. One is for each App Engine instance that you have, they are able to handle multiple concurrent requests, and that's how auto-scaling works for App Engine. On the other hand, for Cloud Functions, one main difference to take note of is that each Cloud Function instance is only able to handle one request. So whenever you have new requests coming in, we will be creating new instances of your Cloud Function to handle each new request. As a result of this, if you have a lot of incoming requests that are going to be coming in, you might notice a scenario where some of the Cloud Functions are exhibiting cold starts behavior. So that's just something to keep in mind. And in summary, let's take a quick look at what we have been talking about so far. So we have looked at the presentation layer and the processing layer as well as the data layer of our full-fledged e-commerce web application. We have looked at how App Engine runs in the presentation layer. We have looked at the processing layer where we have both synchronous and asynchronous operations happening, and also the data layer as well, which we have covered briefly in terms of how our application interacts with the backend. And that is basically the serverless fundamentals section that you have just watched, building with functions and apps. For the other quadrants that we have talked about, serverless beyond compute, data and machine learning, how to take advantage of Google and third-party services, as well as serverless in production, these will be covered in a lot more detail in other sessions, so please tune into those if you are interested in them. Now here are some useful links to help you get started with both App Engine and Cloud Functions today. You can take a look at these 2 pages that are filled with interesting facts, best practices, sample code, and demos and tutorials for you to try out. So thank you for your time, and we'll be back shortly with the Q&A.
And we are back for the live Q&A. My name is Jal. I'm the account manager for Google Cloud. And thank you so much to Hon for sharing on what is the fundamentals of serverless. And in fact, I think I like the way that you actually differentiate between App Engine and Cloud Functions. I guess you guys also resonate the same as me. So I think we are seeing a lot of questions coming up from an audience. So I think without further ado, let's start with the first. So what are some best practices for working with Cloud Functions?
Oh, that's a great question. So whenever we work with Cloud Functions, there are certain best practices that we need to keep in mind. The first one is the concept of idempotency. That is, you have to make sure that when you are developing your Cloud Functions, that they have no side effects. So that means that when you retry your Cloud Functions multiple times, they don't change the state of the world. In that case, that makes it extremely safe to keep your Cloud Functions running and retrying for multiple times. So the other thing to take note of is that you shouldn't be starting any sort of background tasks in your Cloud Functions. The reason for that is because when a Cloud Function terminates, your code is no longer able to access any background resources. And then when a Cloud Function instance starts up again, that job might resume, and then this often leads to complicated or subtle bugs that are hard to troubleshoot and diagnose. The other thing is that should you be creating any kind of temporary resources when you're working with Cloud Functions, be sure to clean up those temporary resources before your function terminates in order to avoid taking up extra resources. One last thing to take note of when working in Cloud Functions is that previously I mentioned Cloud Functions can be triggered by emitting events. However, there's also another way in which Cloud Functions can be triggered, and that's through a vanilla HTTP request. So if your Cloud Function is being built to respond to a HTTP request, you need to ensure that it is also returning the appropriate HTTP response code when it terminates, so that it shuts down cleanly. And those are just some of the best practices to keep in mind when working with Cloud Functions.
Thank you for the best practices. And I think I have someone asking, what are the examples of use case of Cloud Functions?
Okay, so there's a few very popular use cases for Cloud Functions. So the first one is what I briefly covered in the presentation earlier, which is in terms of image resizing. Think of when a user uploads a photo to Google Cloud Storage. Usually in a typical business application, there's a lot of other things that need to happen after that. You need to extract the image metadata, you need to resize the image, you might need to crop the image, you might need to create a GIF out of the image or a thumbnail. So these are all scenarios in which a Cloud Function will prove to be useful. After the user uploads it, Cloud Storage will then emit an event, and then you can then develop a Cloud Storage to pick up on that event, to be instantiated and do whatever image processing that you need. So that's the first example of a typical use case for Cloud Functions. Now, the other use case for Cloud Functions, which we see a lot, is in hooking up to message queues. So a lot of people tend to want to use Cloud Functions when they actually publish a message to a queue. And then that's when a Cloud Function will wake up and do some kind of processing to extract data from the queue and pump it to maybe your data lake or your data warehouse. So that's a great scenario in which Cloud Functions can come into play.
Cool. Another question that I think we see is that when should I use App Engine versus Cloud Functions?
So that's a very interesting question. And in order to answer that effectively, let's think of our application as a whole in terms of a typical line of business application. In a typical line of business application, we have the main web application that most people are going to be familiar with. This could be an e-shop that we have looked at just now, or it could be some other business application that you're developing for your company. In this case, the rule of thumb is that if you're developing a web app in a web application framework, then App Engine would be the best choice for you in this case. However, if you find yourself developing a lot of extra little pieces of code, and you're finding that you're having to sort of put it inside your main web application where it doesn't really belong, but you just have to sort of slot it in, that's when you should think about breaking these out into microservices, for example, in the form of Cloud Functions. These could be things that are not entirely related to your main business application. Taking the example of an e-shop, for example. You really want to be focused on letting the user shop, check out, purchase items, upload their own items for sale. When it comes to things like data analysis, extracting data from your shopper's orders, for example, putting it into a data lake, extracting image metadata, things like resizing images. These are functionality that are not part of the core functionality of our web application, and these would be very well suited for Cloud Functions. Not only does your code not have to live in the main application, by putting your code in these Cloud Functions, you're able to compose them in many different ways as well if you have new business functionality or new business requirements without having to refactor the code out of a business application or adding more code on top of it. So these are some sort of general rule of thumbs that you can use when deciding between App Engine and Cloud Functions.
I guess you guys have found it very informative. Really, thank you. The next question that we have is, how does App Engine serving work?
So let me quickly talk about this. So in this context, I'll take it that the question is asking about serving static files. So one way the App Engine serves static files is through a deployment descriptor in the form of a YAML file, for example. You deploy an App Engine app through a YAML file, and you can describe certain file handlers inside your YAML file to tell App Engine how to serve up your static files and assets. So it's very straightforward, and you can look at the documentation for some examples of how you can do that.
Thank you, Soo-Hon. So I guess now we are going to move on to our next segment, which is Serverless by Compute with our practice lead, Yi Liang. Thank you so much. See you again.
Thank you.
That, in a nutshell, kind of differentiates between an App Engine and a Cloud Function. Okay, it looks like the serverless track is completed, and the folks who attended the serverless track is now back with us. So now we have folks who attended the serverless track as well as the CI/CD track now back and looking at me. Okay, so let me do a quick introduction of what we're going to do in the next session. So in the next session, in the serverless track, now that you've seen functions and applications, Well, we're going to get a very, very good engineer to walk you through the serverless capabilities of Google Cloud Platform around data and machine learning. So Yi Liang is our machine learning engineer, right? And he's based out of Taiwan. He's here in Singapore, and I can't wait for him to show you what he can do, right? In the CI/CD track, we're going to carry on a little bit further based from what we discussed in session 1, and we're talking about architecting for continuous integration and delivery using Google Cloud. So for that session, we have Henry, who is our SKE. SKE is actually spelled SCE. So what does it stand for? It stands for Strategic Cloud Engineer. The success of a strategic cloud engineer, and that's why we call it SKE for short, because it's quite a tongue twister, is Henry spends a lot of time on site with his customers, helping them overcome technology as well as usage issues so that they can leverage the most out of the Google Cloud Platform. So please attend the CI/CD session and pay attention to Henry and what he has to say, because he is a really hands-on guy. So one other interesting thing about, let me repeat a little bit for those who actually attended the serverless track. I mentioned earlier, while the CI/CD track folks are here, about what they're missing, right? So one interesting fun fact is the icon for the App Engine. What do you think the icon of the App Engine looks like? So I explained that if you stand at the back end of an F-16 fighter jet, you will see the engine exhaust coming out towards you with flames, and hopefully you don't get singed. And then you see the ailerons and the rudder. And that's basically is the inspiration for the App Engine icon, where what we're trying to denote is that the application developers can just focus on writing good code, and then we take care of the rest. No worries about CPU, RAM, auto-scaling, when do we scale out, when do we scale in, right? It's all just a matter of configuration, and you declare to the App Engine, in what kind of conditions do I scale out, and then we decide when to scale back in, right? And that's the magic. So we can do that because of our own adoption of containers. I've also mentioned earlier that we cycle through millions of containers in a week at Google. Right, so here's an interesting fact. When we're going to go into the next session around the serverless for data and machine learning, one of the interesting, and personally this is an interesting topic of mine as well, is BigQuery, right? So BigQuery has been around a while as well, and BigQuery is actually an externalization of Google's capability to give you the ability for how we index the internet. So the same engine that Google uses to index the internet and to do data and analytics is now available for you via the Google Cloud Platform. Now, the BigQuery has been around in the Europe region, been around obviously in the North America region. In the Asia region, it is available out of Japan. We are very happy and delighted to announce that starting this year, you can expect BigQuery in the region closer to you in APAC, from India to Singapore to Taiwan and to Australia. So these are the areas, the regions that we now have BigQuery. Now, in a very short time, we will be resuming and going back into our 2 separate tracks, where track 1, which is serverless, and talking about the serverless capabilities of our AI, ML, and data. And then in the second track, CI/CD, we're talking about architecting for continuous integration. One final thing, if you're joining us new, fresh, you have missed out the previous session, no worries. You can continue with this session, and then all the sessions will be available for replay a few days down the road. Now, very quickly, in the last 20 seconds, just a matter of navigation. If you hover your mouse over the screen, or over my nose if you want, and on the right, you have a couple of icons. Click on the Cloud Hero icon to register. Click on the Q icon to ask your questions live, and we have moderators ready and able to answer them. So we look forward to your continued participation, and I hand you back to the sessions.